Okay, so 4.5, addition, the adding and subtracting of fractions. So last class we talked about multiplying fractions. You know, all you have to do is multiply across. If we have 2/3 times 4/5, that's 2 times 4, 3 times 5, that would be 8/15. When it comes to dividing, if we were to take those same two fractions and divide them, we have 2/3 divided by 4/5. So remember, you change your division to multiplication and then flip the fraction. And so that's why when we go over here, we're multiplying by 5/4. And once you convert it to multiplication, you go ahead and just multiply or follow the same rules that you would in the multiplication process. So you multiply 2 times 5 and then 3 times 4, which will give you 10/12. If possible, you reduce. You know, we had 2 that's in common with both the 10 and the 12, so we cancel those out. And that left us with 5/6. And then here was just if you would decide to reduce first and then multiply, either way you should get 5/6. So don't forget, whenever you're multiplying, you can multiply first and then reduce, or you can cancel out the 2's first, reduce first, and then multiply. But either way, you still should get 5/6. So that's what we did last class. Remember, when you're looking at your fractions, you don't have to have any type of common denominators when it comes to multiplying and dividing fractions. But when you're adding and subtracting, you have to have a common denominator. So when adding and subtracting fractions, you have to have a common denominator. Multiplying, dividing, do not need them. Adding, subtracting, need that common denominator. All right. Questions before I scroll up? Everybody good? All right. So if you have common denominators, then all you have to do is add or subtract the numerators accordingly. So if I have 1/4 and 5/4, and I want to add those together, because I already have common denominators, I don't have to worry about the denominator. I will add the 5 and the 1, which will give me 6/4. Notice that your denominators stay the same. So we have 4 and 4, so that 4 is still there. And then we can reduce by 2. They have 2 in common with both numbers. 2's cancel and leave us with 3/2. And of course, we're not going to always have common denominators, but we'll look at that soon. But we're just trying to make sure we're okay with the process if we already had common denominators, or once we get those common denominators, how we will handle it. All right. So the same thing happens here. We have 2/15 plus 1/15 minus 13/15. You have 15 in each denominator. So we can go ahead and add and subtract them accordingly. 2 plus 1 is 3. Minus 13 would be -10/15. 10 is 2 times 5. 15 is 3 times 5. That negative is still there. The 5's cancel and leaves us with -2/3. All right, problems before we scroll up. All right, so when we have uncommon denominators, we want to look for the least common denominator. And so that least common denominator, LCD, is the smallest number that each denominator can divide into evenly. So we're not talking about what can divide into them. Sometimes I'll ask, what's the least common denominator of 6 and 4? And somebody may say 2. But that's not the least common denominator. That's the least common factor. We're talking about what's the smallest number that both of those numbers can divide into, not what can divide into them. So the smallest number that both 6 and 4 can divide into would be 12. That would be your least common denominator. All right, that's the smallest number that both 6 and 4 can divide into evenly. All right. Let's scroll up. Just want to make sure I don't want to go too fast. All right, so if I go to add 1 over 6 and 3 over 4, once I've established that the LCD is 12, that means I want to turn both of my denominators into 12. Because remember, they don't have common denominators. You cannot add them to each other or subtract them from each other. So I need to convert both the 6 and the 4 into 12s. So you need to ask yourself, what times 6 will give me 12? And that's going to be 2. But in order to keep your equivalency, whatever you do to the bottom, you have to do to the top. So you multiply both top and bottom by 2. So it would be 2 12s. Then you ask yourself, what times 4 will give me 12? And that's 3. And once again, whatever you do to the bottom, you do to the top. And that'll be 9. Once you have your common denominators, you go ahead and add your numerators. 9 plus 2 will give you 11, which is 11 over 12. Also, since we're in Zoom now, I have this the window, the camera window. And sometimes, well, I haven't been able to figure out how to pin it down to get it off of the right side of the video. So don't forget, whenever I'm scrolling up, if you pause right here, basically what happens is I have the video right here and I need to look up how to move it from there. But even though I've moved it on my writing, on the videos, it still pops up over here. So don't forget, when scrolling or looking at a video, you can pause it and write, and stuff like that. So don't forget you have that option. And sometimes people forget, you have that option to do that. So, all right, so let's go through a few more. Looking at 7 over 10 minus 1 over 5. The smallest number that 10 and 5, because remember, it's always based on your denominators. The smallest number that 10 and 5 can divide into evenly would be 10, because of course 10 can divide into itself as well. So the first fraction will stay the same, 7 over 10, but now I can turn that 1 over 5 into a fraction with a denominator of 10 by multiplying top and bottom by 2. Then that will take us here, 7 over 10 minus 2 over 10. Then I can reduce that by 5 in both cases. If the 5 cancels out completely, if everything cancels out completely in your numerator, then you're still left with 1. That's what happens here. The 5 cancels out into the 10, but leaves us with 1 in the numerator. And so that'll be 1 over 2 as my solution. You don't have to worry about this over here. That was just I'm pretty sure somebody asked me a question about reducing. We have 25 over 15, reduce both top and bottom by 5, that gives us 5 over 3. Here probably was saying that 13 over 5 cannot reduce. And so you can leave your answer like that. That's all that was about. Trying to erase this stuff so we can walk through it. All right. So in this next one, we have negative 4 over 15 minus 1 over 10. Our LCD is 30, talking about smallest number that 15 and 10 can divide into evenly. If you go down, check your multiples of 15 and check your multiples of 10. 30 would be the smallest number that both can divide into evenly. So you ask yourself, what times 15 will give me 30, and that'll be 2. So you use top and bottom by that, and that'll give me 8 in the numerator. And what times 10 would be 3 to get at 30. That'd be 3 right there. I'll leave the 8. So that's negative 8 minus 3, which would be negative 11 over 30. All right, good. Next one, we have negative 5 plus 3 over 4. Negative 5 as a fraction would be negative 5 over 1. So don't forget any number. Oh, let me do that. Any number standing alone, you can write as a fraction by putting it over 1. And for the LCD, you have 1 and 4 in our denominators. So 4 is going to be that LCD. 4 can divide into itself. And then also you can multiply that 1 times 4. In order to turn into a fraction with 4. So that would be negative 20 over 4 plus 3 over 4. And add those numerators together, negative 20 and positive 3 would be negative 17. Any questions? All right, so we have this next one. Hold on, let me see how much more. Okay. All right, so this next one we have 4 over 5 plus 3 over 6. Our denominators are 5 and 6. So since one of them is a variable, there's nothing else we can do with that. So that common denominator is just going to be 5 times 6. I said 5 times 6, 5 times x. So I was like, that's 3 over 6, 3 over x. Well, if I said 6, I meant 4 over 5 plus 3 over x. And then so the denominator will be 5 times x. So what times 5 will give us 5x? That will be x. Whatever you do to the bottom, I do to the top. And then what times x will give us 5x? That would be 5. And so we're looking at 4x plus 15 in our numerator. And then when we look at our final answer, it's just going to be 4x plus 15 because they are not like terms. You cannot combine those two. One has the x and the other one doesn't. So we have to just leave it as is. All right, any questions? Any questions? Here we're just talking about like terms. If I was going to be able to add them, I would need both of them to either have x or both of them to not have x. So 4x plus 15x would have been 19x. Of course, 4 plus 15 is 19. So either one of those had to be the case in order for me to add them together. But since that wasn't the case, that's why they both stayed. And it was just 4x plus 15. All right, so for this next one, we have x and x squared. The LCD is going to be x squared. It's the same thought process as having 2 in the denominator and 4 in the denominator. You know, our LCD in this case would be 4 because 4 is 2 times 2. So when I look at this, this is just 1x and this is x times x. So our LCD is going to be that x times x, which is x squared. Wherein we will not change the fraction that has x squared, but we will just change the first one by multiplying top and bottom by x. That will change that to 7x. 7x minus 3 over x squared would be our final answer. All right, questions. All right, scroll up. Very good. Let me see how many problems are here. Yeah, plenty of time. Hope I passed it. Let's see what's 4, 7. I guess we can go ahead and keep going. Okay, so we'll probably stop somewhere in between. Probably won't finish 4.6. At least we get started. All right, so 4.6, estimation and operations on mixed numbers. So if we're looking to multiply 7 and 1/2, 4 and 2/3, first thing we should do is to convert them to improper fractions. So that'll be 7 times 2 plus 1 over 2. 4 times 3 plus 2 over 3. And that'll give us 15 over 2. and 14 over 3. All right, so then I broke up 15 into 3 times 5 and the 14 into 2 times 7 just so we can easily see what we'll be able to cancel for us. And we see that 3 can cancel here, 2 can cancel here. In both cases, those 2s and 3, the 2 and that 3 in the bottom will leave just 1 because the whole thing canceled. So you multiply across, all you have left is 5 times 7, which is 35 over 1. And your most simplified answer would just be 35. All right, any questions? All right, next one. Negative 12 times 1 and 7/9. So negative 12 as a fraction is negative 12 over 1. That 1 and 7/9. As an improper fraction, you do 1 times 9 plus 7, and that'll be 16 over 9. So then I broke up the 12 into 3 times 4. 16, I just did 4 times 4. It couldn't cancel out with anything. Notice, as far as the 16 is concerned, all your 4s are in the numerator. Remember, in order to cancel, you need it in the numerator and denominator. But we have a 3 that's in the 12 and the 9 that could cancel. So 4 times 4 times 4 will give you 64 over 3. That's a negative, so negative 64 over 3. All right. And then down here, I was saying that if you want to convert it back to a mixed number, take 3 divided into 64. So it goes into 6 twice. 6 minus 6 is 0. Break down your 4. 3 goes into 4 once. 1 times 3 is 3. 4 minus 3 is 1. So it'll be 21 and then 1/3. All right. Any questions? All right. So division, same thought process. 7 1/2 divided by 4 2/3. Once again, convert them to improper fractions. So that's 7 times 2 plus 1, which is 15 over 2. Then 4 times 3 plus 2, which is 14 over 3. All right, so then going back here, 15 over 2 divided by 14 over 3. Don't forget to flip your fraction and change that division to multiplication. So this fraction stays the same. This goes to multiplication, and then this one, you flip it. So we have 15 over 2 times 3 over 14. And then I was checking to see if anything can cancel. And I see that nothing cancels. And so you just multiply across. 15 times 3 is 45. 2 times 14 is 28. And if you need to convert it back to a mixed number, 28 goes into 45 one time. 1 times 28, of course, is 28. 45 minus 28, 17 as a remainder. And so that would be your mixed number representation of 45 over 28. Make sure we are all right. All right. Any questions? All right, so for the next one, 6 divided by negative 5 and 1/7. Once again, the first move is here, converting that mixed number to an improper fraction. So I did 5 times 7 plus 1, which is 36. So that's what we have here, 36 over 7. 6 divided by 36, divided by negative 36 over 7. So it should be negative 6. All right, so negative 6 over 1 is negative 6 as a fraction. Division changes to multiplication. And then we flip that fraction that follows the divisional sign. That'll be 7 over 36. All right. So we have negative 6 over 1 times negative 7, and I broke up the 36 into 6 times 6. So one of those 6's will cancel. And also negative to a negative turns positive, so they cancel as well. So you multiply across, that's 7 times 1, and then on bottom, 6 times 1, which is just 7 over 6. And once again, if you want to convert it back to a mixed number, 6 goes into 7 one time, and then 7 minus 6 will be 1, so it's 1 and 1/6. All right. Questions, questions, questions. All right, so we're going to pause right here, and we'll get into adding and subtracting and estimating next class. All right. So any questions on anything that we've done up to this point? Questions, concerns, comments? All right. So once again, we'll be doing Zoom this point forward. Oh, also, we got a Super Bowl coming up. Well, it's Sunday, and I'm going to do something. I know, right? You know, we got the Tampa Bay Buccaneers and the Kansas City Chiefs, for those who don't watch football at all. I'm going to probably create something to put in WebAssign that you guys would just have to respond to, you know, as far as the winner is concerned. Might do a score thing too, but we'll see. I'll put all the directions. Just look out for your emails, and I'll put all the directions in the email. So just an easy way to answer points. Has nothing to do with mathematics or anything like that. Just shoot your shot and add a little spice to the Super Bowl. You know, add a little fun to the Super Bowl. So yeah, so we'll do that like that. And like I said, look for the directions. I'll send something out shortly. But any questions or concerns before we close out today?
I do.
Mhm.
So being that we are on Zoom, are we gonna get a link each time, or is it the same ID code?
It's gonna be the same code that I sent you in that email.
Okay.
Yep. That same one you clicked on to bring you here today will be the same one we use for the rest of the semester.
Okay.
Now, I will say this, if we were to schedule an office hour, then I would give you a different code because that would be something completely different. But that one will work for the rest of the semester. Yeah, thank you. Good question. Good question. All right. Anything else? Anybody else before we close? All right. So you guys have a great day. Be safe, and I will see you on Friday. Yep, Friday. Friday.
Thank you.
Thank you. You have a good one.